Okay guys, we're back again to continue this, and where we left off was setting up these two tubes of fluid using the thermometric property that if we heat it, it expands, cool it, it contracts. And we could use water in here, we could use other kinds of fluids. The problem with using water in a temperature thermometer is because below freezing it starts to expand, and that's actually around 4 degrees it starts to expand, and we run into some trouble with that. So alcohol thermometers used to use mercury, toxic. Alcohol, and add some color to it just so you can really see it. So, alright, so we're back here trying to formulate a conversion from Fahrenheit to centigrade, or vice versa. We start out at Fahrenheit, we have to take our Fahrenheit, and to get them to start out the same points down here, 0, we have to actually subtract 32 from Fahrenheit. That gets them both starting at 0. Okay? But that isn't enough. That lines them up with 0, doesn't line them up the other way. Then we have to take that temperature and multiply it by a ratio that'll get it to go from 0 up to 100 instead of 0 to 112 or 180, because there's 180 of those. Okay? So if we take this by 100 over 180, that reduces to 5 over 9. We come up with this equation. And we can test it. If I put 32 degrees in there, 32 for Fahrenheit minus 32 is 0 times 5, still 0, 0 equals 0. That checks out for our lower point. If we check our boiling point, I put 212 in there. 212 minus 32 is 180, right? And then 180 times 5 over 9 gets to be 100. So our 212 and our 100 match up. So that becomes a valid equation for us to convert from Fahrenheit to centigrade. If I want to go to centigrade to Fahrenheit, all right, I just sort of clean this up and rearrange it. I get 9/5 times centigrade, add 32 equals Fahrenheit. And what I've really just done is rearranged that upper equation there and solve for Fahrenheit. Okay? So you'll be responsible for this on the next exam. The one we have to include in here is that thermometers compare really well. They're fairly accurate between freezing and boiling. Once we go above boiling points or below freezing points, the accuracy or the lining up of the different types of thermometers really isn't very accurate. So we have to introduce what's known as the Kelvin. Okay, Kelvin is based on pressure and temperature and volume being related. Volume and temperature being rated through Boyle's law. We won't get into that. But it basically means if I take the pressure all the way down to 0 to give me an absolute 0 temperature, it comes out to be at minus 273.15 degrees centigrade. Okay? Refer to that as absolute 0. That's when the average internal kinetic energy goes to 0. That means the velocity goes 0. The idea means at absolute 0 there is no movement at all. No energy is left in that material or fluid. So to get the Kelvin to there, we basically just have to use this 273 from the Celsius, and that'll be our conversion there. All right. So Kelvin 0. When Kelvin is 0, Fahrenheit is at Celsius is at minus 273.15 degrees centigrade. Okay. There's more in the book and the lecture notes about that, but for the exam, just to get you through, this is one of those slap problems, so I'll put my hand over here, right? Slap. That you need to know how to convert temperatures. Alright, so for exam number 4, you're going to see a conversion temperature. I'll give you one temperature in either centigrade, Fahrenheit, or Kelvin. You convert it for the others. Okay. Now there's more in chapter 13. It talks about expansion and contraction. It gets into Boyle's law and some gas laws and things like that. But this is really what you need just to get us through for this introduction. Okay? Hope that helps. Check out the notes, and we'll see you in the next video for 14.